Okay, good evening, everyone. Okay, welcome to our AstroCafe session for the month of October. Okay, tonight we have a special theme, which is we are going to talk about Mars. Okay, in conjunction with the Mars opposition, which is going to happen next week. Okay, last week we had the closest approach, and next week we are going to have the opposition. Okay, first of all, my name is Michael. I'm the host for tonight. Okay, and let's welcome our three speakers for tonight. Okay, first is Dr. Chong, okay, the president of Astronomical Society of Penang. Okay, and then we have William Chin, okay, vice president of the Starfinder Astronomical Society. And it's finally C.K. Lim, is a committee of our Astronomical Society of Penang. Okay, so
Michael, you introduce yourself also.
I'm the committee member of the Astronomical Society of Penang. Yeah. Okay, so let's start. So what's the fuss about this Mars opposition? What's so crazy about this? Dr. Chong, would you like to have a brief introduction about
I'll have a brief introduction on Mars, Michael, and then I'll talk a bit about this week is also our World Space Week. So remember, for the Mars opposition occurs about every 2 years long, 2 years and 2 months. So this is the week. So 6th of October, this week on Tuesday, Mars closest approach. And then next Tuesday on October the 13th will be Mars opposition. And these are not bad because Mars is about 22.6 arc-second. Not bad. All right? So these are quite close. And but that was still, I don't know whether William Che can remember, Chung Che can remember, August 27, 2003, when Mars was the closest to the Earth in the past 60,000 years. 25.6 arc-second. Very big. But this time, not bad also, 22.6 arc-second. All right? So, and now on the way to Mars, you know there are 3 missions. The United Arab Emirates Hope mission, the Chinese Tianwen Yihao mission, and of course the American Perseverance. I'm going to talk more. Later on, I'll let our William talk and Chung Chia talk. I'll just go back to International Space Week. So this is our International Space Week, which is recognized by the United Nations. So it's under United Nations. So this year, as usual, is always organized in the time of first quarter moon of October. So 4th of October to the 10th of October. All right. So tonight is the last day of this World Space Week for this year. So there are 90 over countries in the world celebrating, and it seems I checked, there are about more than 4,000 events going around the world. You know, but in Malaysia there are only a few events in KL and so on. All right. So, for example, I think yesterday was Dr. Faiz Kamaluddin, our Angkasawan candidate, interviewed about Mr. Sam Gibson. All right. So, all over the world. And there are certain countries like Brazil, a lot of events, you know. And the most event in the world, you know what? Not USA, not UK, Pakistan. Even many schools in Pakistan, they put in their website. All right. World Space Week. So, they are doing a lot of things. So, they usually have a team every year. So this year the theme is Satellites Improve Life, all about satellites, no? So many of the schools, organizations, science centers, astronomy centers in the world, they're talking about how the satellites benefit mankind, right? So remember, man is on the threshold of colonizing the moon and Mars and the solar system. So now I think the man's outlook must look outwards towards the solar system, right? The future of mankind is the solar system. All right. So I pass over to Chung Chia and William. All right.
So Chong, can you explain a bit about opposition? What is an opposition? What's so special about this?
The opposition is like this. Opposition means when you look at it, the sun, the Earth, and Mars is more or less in a straight line. Looking from the top, looking at the plane of the ecliptic, the sun, the Earth, and Mars is in a straight line. But looking at the edge at the plane of ecliptic, it's impossible for the sun and the Earth and Mars to be always in a straight line. But on the plane of the ecliptic, it's possible to have the three in a straight line. So this is it. That means what? Around midnight, you can see Mars vertically overhead around the world. From in Malaysia, Mars is vertically overhead. You are in Japan, you have to look a bit towards the south. You are in Australia, you look towards the north. That means Mars will be very close. And it is seen at midnight. But Mars closest approach was 6th of October, this past Tuesday. So that was Mars is the closest. So as I speak now, sorry guys, please observe Mars. Mars every second is flying away from the Earth at many kilometers per second. So Mars is getting slower and slower. That means yes, yeah, Ben. So that means on 13th of October next week, Earth will overtake Mars. Remember, Earth is it's the third planet in the inner planet, so Earth is moving faster, orbiting the Sun. Whereas the fourth planet, Mars, is on the outer lane. So on the 13th of October, opposition time, Earth will about to overtake the Mars. So that's called Mars opposition. So usually the best time to observe any planet like Mars, Jupiter, Saturn, and so on is at opposition. So that is what they call vertically overhead and about the closest to the Earth. So that's called the opposition. So we have our member here. Can you come and show please? Come, show our introduce everyone here. Show please here. You're here. Dr. Benjamin Lim. No, here. Ben is with us. Dr. Benjamin Lim. He just got his PhD in pure mathematics from Stanford. He's back already. All right. Okay, I pass over to Sunchep and we will. Yeah.
I'll take over. I think after we can take over. We are trying to shoot live from the observatory in the southwest portion.
Hey, you mute your mic, CK. Your mic is mute.
Oh, I think CK is going to share his what you call that observation right now.
I don't think so because CK, your mic is muted.
Okay. You have to unmute.
Off the speaker.
Okay. Oh, the iPhone is very strong.
Yeah, because Ben, I think Ben is watching the live.
I'm sure.
Okay. Very sorry. I think somehow my mic is actually interfering with his mic, not his mic interfering with mine. So even if I on mine also, if I on mine, okay, but then if we on off his also, it's not wrong.
But it's okay, you
Okay, as long as one of you have the mic on, it should be okay.
Yeah, yes. I'm using Dr. Chong's mic, so I hope that you can hear me. I'm talking a bit louder. So we are shooting. We hope to shoot live from Bali Pulau in Penang. The sky now is clearing up a bit. I think we still have a bit of chance to view at Mars. We are trying to look through the 14-inch telescope from my back here. This is a 14-inch telescope which I usually use to take photographs of the planet. Okay, now back to the question: why is so like what's the fuss about this Mars opposition? Actually, among all the planets, actually, I found that Mars is actually the most interesting one because if you know about astronomy, our four inner planets are terrestrial planets. That means Mercury, Venus, the Earth, and Mars is actually a terrestrial planet. Terrestrial planet means something that the planet has a land, you can step on it. So it's a terrestrial. And the other four outer planets, that one is Jupiter, Saturn, Uranus, and Neptune. That is not a terrestrial planet, but a gas planet. So what you see is actually the cloud top of the planet only. You don't see the ground. There's no ground for the planet. So it is all like cloud kind of feature. Okay, so if you were to go to the outer planet, for example, Jupiter or Saturn, if you fly there, you cannot land there. You will just sink inside and deeper and deeper and deeper. Okay. So back to the inner planet. Of all the four inner planets, actually Mars is of course, other than the Earth now. Other than Mars, you have the Venus and Mercury. Both these planets, actually, in terms of astronomy, for amateur astronomy, they are not very interesting because one, Mercury is quite small, near the Sun. You cannot see much feature there. Venus, not so near the Sun. Sometimes appear quite big, but the problem is that Venus, you cannot see the ground of Venus also because it's all blocked by a thick cloud of gas. Okay, so that's also not so interesting. But on the other hand, Mars is actually very interesting because Mars we can actually see like the Earth. Okay, we can see like the Earth, we can see the ground on the Mars. Sometimes we can see some cloud-like feature on the atmosphere and things like that. And you can see the polar ice cap, the north polar ice cap, the south polar ice cap. So it's very interesting. And compare Mars and the Earth, they are quite similar in terms of rotation. I mean, like one day on Mars is I think something like 25 hours or something like that, 24 hours plus. So they are quite similar to the Earth. And unfortunately for Mars, because for our 1 year on the Earth is actually one year. We go around the sun, what we call as a 1 year is 365 days. But for Mars, it's different. Mars is in the outer orbit. So Mars have to go around 1 year, go around the sun. It actually took about 2 years plus to go around one rotation. Okay? So the problem with that is that we can never get close to Mars all the time. We only get close to Mars every 2 years. You know, every 2 years and 2 months or something like that. Because why? It's like we are going down the stadium. We are in the inner lane of the stadium. Mars is on the outer lane of the stadium. Mars will take much longer time to go around. So by the time you go one round, Mars will be on the other side of the stadium. Then you have to go another one round, then Mars will catch up. Okay? So every 2 years plus only you can see Mars once. And not every 2 years is the same one because sometimes Mars will get closer. Sometimes we get further, all because of the orbit. Okay, the orbit. Our orbit is that I'm showing you. Let me see. I'm going to share my screen. I hope it works. It works just now. Let me try again. Share my entire screen. Select Windows screen. Okay. Okay. Let me see if you can see that. Okay. Now I'm sharing my screen. Right? You can see, right?
Can.
Can you see there's a Mars there, right?
Yes.
Okay.
Yes.
So you see, this one is a photo of Mars taken in 2014. So we have a Mars composition in 2014. Then we have to wait for another 2 years. Then 2016. Then wait for another 2 years. 2018. Then we have to wait for now 2020. Okay. So 2018, 2020 is a good year for Mars because it comes very close. Now it's 2020. If you don't see it now, the next time you see it in 2022, which is before it's Mars composition again, it will still be small. I don't know what's the number like. Maybe some will help me later, but it will be much smaller than now. Okay.
Sorry, CK. I accidentally mute Dr. Chong's microphone, so can on back. Only he can on back.
Okay, on already.
Sorry.
Okay, really, right?
I forgot you are using his mic.
Okay, it's okay,
Okay.
Okay, sorry. Okay, so I hope you didn't miss anything. But anyway, so this is the 2014 one of the year where the Mars opposition, and you can see that in 2014, Mars actually do not get bigger than 14 arc-second. What is this 14 arc-second? 14 arc-second is actually the angular diameter of Mars. Okay. Most of the time in the astronomy world, we don't say the Mars is how many thousand kilometer in diameter, Earth is how many thousand kilometer diameter. Most of the time for us, we usually refer them with how big they are in the sky. Okay. For example, we have the moon. Okay, the moon is actually smaller than the Earth, but it looks big in the sky. Okay. While you have Jupiter, which is much bigger than the Earth, but it looks so small because it's far away. Okay, so when we do that, we don't compare them because when we look at them, we usually look at the angular diameter in the sky itself. So for the angular diameter of Mars, it's actually, if you say the general world, it's actually very small. It's like 14 arc-second. For the 2014 opposition, the biggest it actually gets 14 arc-second. Arc-second is very small. 1 arc-second, 60 arc-second is 1 arc-minute. 60 arc minute is 1 degree. So it's like, this is like so small as well, okay? But then in astronomy, in amateur astronomy, if you look at Mars, it must go to a diameter of 10 arcsecond and above, we consider it good enough to view. And you can start to see detail. As you can see, the one on this side is only 8.4 arcsecond. That was in January 2014. Okay. Then in in February, it started to grow 1 arcsecond bigger, slightly bigger, not too bad. Then 10 arcsecond, wow, starting to get bigger. You see, even by 2 arcsecond, 10 arcsecond versus the 8 arcsecond, you can see that they are size different. Although they are 2 arcsecond different, but it's actually 25% bigger already. From 8 to 10 is about 25. Is it 25 or 20% bigger already? So by the time go to opposition on that year, we have 14 arcsecond. Oh, it's good. 14 arcsecond is not to say the best, but then okay lah. We cannot jump already because Mars is always like that one. It's always small one. It's always on the region of 14 arcsecond. But then when it's coming, for example, you see, on the 2014 is 13 arcsecond about 14. On the 2016, the 2 years later, on the opposite, actually grew up to about 18 arcsecond, which is actually impressive size. 18 is quite impressive. Then 2 years ago is supposed to be a very good year for Mars. 2 years ago, everybody was waiting. In fact, 2 years ago, Dr. Chong, I think myself and anybody have seen the Mars opposition in 2003. We are waiting for 2018 because Mars will get bigger already.
Yeah.
But then when the Mars actually gets big, we have a problem. There's a dust storm on Mars on that year.
Global dust storm.
Global dust storm. It's not a local one, it's a global. It engulfs the whole planet, and in fact, for the 1 month prior and 1 month after the Mars opposition, if I can remember correctly, we are totally wiped out. We cannot see anything. That's why it was the biggest Mars that we have seen since 2003. But then we cannot see anything. So it's a waste. And this year is our last chance to see. That's why it's so interesting. This is our last chance to see. It's the last time we can see that Mars is about 22, 23 arcsecond. And after this year, I believe we'll drop back to 14, 16 arcsecond. And we have to wait until 2035. So 2035, I don't know any of us. Maybe I think very difficult to say. Another 15 years, another 20 years. It's up to you. But then
stay healthy. Stay healthy,
yeah. Stay away, yeah. Keep a distance. That's why I'm sitting far away from Dr. Chong right now. So, but anyway, this is the year. Hopefully, we can show you what's so interesting our Mars. I hope the sky will clear. Okay, will clear, and we hope to see live. We'll show you live view of the Mars. Okay. So for the moment, I maybe pass back to either William or Dr. Chong to give you more insight of the Mars. Okay.
William, you can give your experience on Mars. William.
Yes, Dr. Chong. Yeah. So actually, what I'd like to share today is the what I call experience, observation experience. So my first sight of the Mars through the telescope is about 1995. Is about how many years ago? 1995.
25.
25 years. Oh my God. Okay. So
no. Yeah, 25. Correct. 25.
So that time I still don't know how to read the photograph. And then people keep saying that if you look at the Mars, you can see the polar ice cap on the Mars, north and the south. And then that time also I don't know the Mars, the rotation axis of the Mars is actually tilted like the Earth. So then I thought that both sides of the polar ice cap also can see, but always we only can see one side of the polar ice cap, and sometimes we cannot see it. Sometimes you cannot see because of what I call that. The axis, the North Pole and the South Pole is just right. What I call that. the angle is just right, and then it just hides like something like that. So that is a very interesting thing. And then until 2003, then I saw someone took a picture of Mars and other planets, very nice. So I go to ask them, hey, what you are using? They said they are using webcam. Well, that will be another exciting thing, because we never thought that webcam can do this type of things. So back to the question, if just now why we are so on Mars, because I think also because of this every 2 years and roughly 2 months we only can observe
6 months.
Something like that. Yes. So that's why we not always we can observe the Mars. Not always we can observe Mars. Only 2 years and 2 months, something like that. Then only we can observe. So we gonna get the chance to observe it. And also just now CK also talking about the size of the Mars of every opposition is different, right? Just now you have shown the image. Yeah. So that thing also make us that we would like to grab the chance of this. Actually, 2 years ago, and as well this year, 2020, the apparent size of the Mars is quite big, and then we can see much more detail on the surface of the Mars. And yes, Mars is the only planet that have a solid surface and also that has an atmosphere. And the atmosphere, the activity on the Mars atmosphere actually very similar to the Earth, because they also have some water vapor on Mars. Then the cloud will form on the Mars atmosphere, but depends on the distance of the Mars, Mars and the Sun. So sometimes the Mars come closer to the Sun, and then you will get more energy, and then the atmosphere of the Mars will not easy to form the cloud. This is what I observed throughout the from 2003 until today. Why I say that? I show you some image. Hold on.
By the way, let me add some comments. So actually, I would like to make a little bit addition, or I would say correction about the Mars thing. Actually, we can see the Mars every year, not every 26 months, every year, but it will only get big every 26 months. So actually every year, every month we can see, just it will be very small. So every 26 months, it will go through a cycle where it get close to the Earth, what we call the opposition. It will reach the opposition every 26 months, but in between we can actually still see it, but just become smaller.
And also the angle from the Sun is
So it reach a position every 26 months or so, but in between we can still see it, just that very small, not so impressive.
That's a thing. So okay, this image I took in back in 2003. That is what the Dr. Chong talked about just now. The closest
60,000 years.
The closest we got.
The biggest in 60,000 years.
Yes. So also the same as what CK showed. I used the same setup, and from July until October, I just use the same setup and then take the Mars image. So you can see the size of the Mars actually changing due to the Earth distance and the Mars distance. So it become bigger and close to the opposition, and also closest to the Mars. Then it will fit, because the Earth already bypassed the Mars, and then Mars, the Earth and Mars, between Mars, the distance is further away. So it becomes smaller over here. This is taken in 2003. I think after that, I never have chance to collect this kind of Mars image again. I think.
Let me add something. So when you sent me this picture in 2003, I was teaching astronomy course in USM law. I wanted every of my students to print this. If possible, A3 size. I gave it to my students to print. Very impressive. And we organized a 1 week astronomy fever event in Island Plaza Shopping Complex, Tanjung Tokong. So every day we observe it. So those of them, there are two things. They have to observe through the telescope, and another student will ask the person who observe, what's the color of the object? Blue, no certificate. It must be red. So we give them a certificate. And then a few days later, we went to KL. And President Nagara, the weather was no good, but we went to what is called National Sports Stadium, Bukit Jalil. Wow, thousands of people were there. And they gave the Mars certificate. Wow, like no time to sign, just give them money.
I remember that. I also at this Bukit Jalil that time.
Yes.
And then show the public about the mass live through my computer screen.
That time, I'm yet to join Dr. Chong. I only joined in 2004.
Yeah.
You know that
I missed the 2003.
Yes, you miss it, yeah. That time
and miss it again last year. So miss 2003 and miss 2018.
Yeah. 2018 actually I also miss it actually.
Hopefully 2035 I'm still around
hopefully because I must still keep myself around this world because I never see this heli comet yet. Yeah. So, but I'm very lucky, although I don't have this kind of collection after 2003, but seems that every 2 years, I still got chance to observe it, at least around the opposition time. So that's why you see most of the Mars image is very round, but only except this one, 2016. I think I missed the opposition time of the 2016, but 2018 I also missed it because if you can look at it, this is not the round shell of the Mars. So this is kind of like have a faces because this is not yet the opposition. So the Mars will not become round. And this is only a sample from the 2003. And this is 2005. Actually, the 2005 angular size of this Mars very close to this time. So I also didn't miss the 2005 opposition. And if you look carefully, I think I have put all the Mars south down and north up, so then you can see how the polar ice cap appear throughout all the image. I think this one I inverted. I think this one also the same. So all the Mars north up. So then you can see in 2003 we can see the south polar ice cap, and then this one not very obvious as this time also. If you have chance for these few days, you will notice that we might not can see more on the polar ice cap, maybe a little bit. And this one, this is the 2008. Then the north polar ice cap start to appear, and 2012 also you can see the north polar ice cap, and also this one. And 2016 also cannot see. I don't know why, but because of the image, I think. And then 2018 you also can see the southern south polar ice cap of the Mars. But this year I also did miss the opposite, the closest opposition not yet is on next week, right? So but the closest of the Mars I did miss it, so I also have the image of it. I don't know if I have here or not. Okay, this one, yes. This is taken on the night of when the Mars and the Earth is closest. It's about
6th of October.
Yeah, this image actually taken on 12 o'clock midnight, around 12 o'clock midnight. And then the Mars closest to Earth is on around 10 o'clock. So it's 2 hours away. That means this is not the closest, but very close to the closest, 2 hours after closest. So you can see the features on the Mars actually. You can see the south polar ice cap becomes very small like that. Because I think because of this time the orbit of the Mars also close to this what you call it, perihelion, like the Earth orbit. I don't know what to call the orbit the Mars closest to the Sun.
Yeah, it's called perihelion also.
Perihelion also, right?
Yeah,
okay.
Because it's referred to the Sun, so it's perihelion. So they called it for the biggest approach, like last year they called it a perihelic opposition or something like that. So where the opposition happened at the perihelion point.
Yes. Yeah. Why I suspect like that? Because every time when we observe the Mars around August to October, you will see less cloud on the Mars. If you look at this image, you will see that usually opposition around this time is around August and October. You will see less cloud. But then when it goes to other month, you will see the feature on the Mars atmosphere is actually very very many things you can see on the atmosphere, activity on the atmosphere. So that is a very interesting part I can observe throughout the 15 years of cycle of this Mars opposition. And in this image, you also can see some features like this is the highest mountain in the solar system, the Olympus Mount, 27 kilometer high. It's very even higher than the Himalaya. Okay.
Much higher.
Much higher.
Not even higher, it's very much higher.
Himalaya is 8 kilometer, and this one is 27. This is 27. So yeah, Mars have highest mountain in the solar
system. Yeah.
Yeah, and this I grabbed from this Japan's site, one of the websites in Japan, and then it just shows the different size of the Mars throughout the different years of this opposition, something like that. And it also illustrates the weather on the atmosphere, you see. So every time you want to see, if you want to observe the atmosphere of the Mars, the activity of the Mars atmosphere, you're gonna observe it when the Mars is very small. It's not the big one. If the Mars is at a very close opposition, then usually the atmosphere of the Mars will be less activities. I think because of the perihelion effects of the Mars orbit. This picture to show how the Earth orbit relative to the Mars orbit, and then this is 2018, 34.3 arcsecond, the apparent size, and in 2020, where's the 2020? 2020 is 22.6 arcsecond over here. And after 15 years from now, the Mars will be closer also at this size, even closer than during 2033. So yeah, so I think this is what I wanted to share at the moment.
Okay, let me try if I can share something from my phone, because I actually make a table. I cannot share it on my...
you want to horizontal to vertical?
Share screen. Not in my Gmail. Cannot. Okay. Why cannot? Let me choose. Never mind, it's okay. I don't know how to do the share screen from using the phone. Okay, never mind. So, is there anything to add on, Dr. Chong? Dr. Chong, you have to on your mic. Dr. Chong, on your mic. Turn on your mic.
Okay, so why Mars? Why so crazy? People are so crazy about Mars because of one man, one multi-billionaire called Percival Lowell. Right? He's from our Massachusetts state in America in the late 19th century. Amateur astronomer, and he was very rich. And then he built in Arizona, in the southwest part of America, because there the weather is clearer. His Lowell observatory which still exists. And he was the one that started the Kepala Pening Marika. Mars scare, frightening Mars, because from his telescope, a very powerful reflector in Flagstaff, Arizona, which you can still visit, what he saw was a lot of lines and dark features. And I think maybe there's some confusion because earlier than him, the Italian astronomers also saw some similar features. When they use the Italian word canali, C-A-M-A-L-I, to describe those features on Mars. But this Percival Lowell, Italian Nobel law, canali, canals, artificial intelligence belief, alien. In Italian, canali means channel, natural channel of maybe some liquid water. Like he mistook it. Then he built his observatory in Arizona. He was observing for many years, and he drew all the canals, all the civilization features on Mars. So he was the one who started the Mars fever in America and spread all over the Western world. So all the movies about the aliens on Mars, all because of him. But it was only in the 1970s when the American Mariner spacecraft fly by Mars, take a picture. Hey, no canal, got crater, very dry like the moon. So the features on Mars are not canals, they're natural features. So anyway, in the human imagination, in all the science fiction story, in the comic book, Mars means got life. So that's why the main reason why people are going to Mars even now, The United Arab Emirates, the Americans, the Chinese go to Mars is because they have light. The main thing is that there are 4 past rover on Mars already, all right? By the Americans, they have found that on Mars previously there are signs of liquid water previously. But where did the liquid water go? That is the main thing. So the Chinese mission, Tianwen-1 and the Pacific mission, one of the mission objectives is to see the evidence of past life, not conditions suitable for life, no. Evidence of past life on Mars. And see whether also for conditions suitable for life, right? So that's why they are so crazy on Mars, because started by Percival Lowell, but they have seen a lot of signs of liquid water on Mars last time, but now don't know where did the water go. So that's why they want to look for life. But of course, now the box is very open, all right? So now we know that one of the most exciting place to look for life, but Europa, not your washing machine from Europe, huh? One of the big moons of Jupiter, Europa, the thick frozen ice, and below they have liquid water. And remember, some years ago, the 2 NASA scientists came to Penang, you know, for our NASA come to Penang. And later on, 1 week later, I and my students went to Malacca Plantain. We spoke to the 7 NASA scientists. And one of them is working on the project how to drill through the ice of Europa and drop the submarine and study. But they have problems now. All kinds of problems. The ice on top of Europa may move, you know. So the wire with all the signal may break. So that's the problem. So they are very keen on Mars, on this Europa, the moon of Jupiter, because it may have life. So literally now, other than Mars, there are other places. One, of course, is Europa, all right? We have a warm liquid ocean below the surface of the ice. Another one is called Ganymede and Callisto. Ganymede and Callisto are quite similar to Europa. Also got a frozen ice on top. Below, we have liquid ocean. And then, in the past, recently, big news, what? The Akatsuki Japanese satellite and other telescope on the Earth, they found what? Phosphine. P3. Phosphorus in the center with 3 hydrogen atoms. So phosphine molecule, and phosphine is only generated by living organisms. Where? In the atmosphere of Venus, very hot. So they don't understand how there is phosphine in the atmosphere of Venus. So they have found phosphine. So now NASA and other space agencies very keen. The future mission they will send to this what they call Venus to go study more of the phosphine. It doesn't mean that you have little green men floating in the atmosphere of this Venus. At least you have phosphine molecule in large quantities in Venus. That means maybe some microbial life, simple life, they have created it. So basically now, where to find life in the solar system? Many places. Of course, this is still what they call limited to a tiny point in the universe called the solar system, the sun and the 8 planets. But now they have found more than 4,000 exoplanets. Right? So I'm sure now many of the big radio telescopes in the world will point at those exoplanets orbiting other stars to see whether they can detect intelligent radio waves. All right. So light need not be from solar system. It can be coming from the exoplanet. So very interesting. The whole idea of Mars is not because to study Mars, looking for alien. And usually I don't like the word alien because in a movie they are the bad guys. I like to use extraterrestrial, the ET. Right. So why Mars? Life in the universe. Okay.
Okay, so let me try to share my screen again. Just now Okay, so there is hopefully you can see. Okay, so there is one question asking about the difference between the closest approach and the opposition. So actually, we have posted an explanation about this on our Facebook page lah. So a lot of people they seems to be confused about this closest approach and Mars opposition. Why there are 2 dates they are reading about? Okay, so actually this one is due to the orbital shape lah. Because we know that the orbit of our planet is not really perfect circle. They are actually ellipse. So ellipse, that means, given that the ellipse, the 2 ellipse, or let's say we are looking at the orbit of Earth and Mars, they are both ellipse and they are not aligned at the same point. Because in no ellipse, there are 2 foci, okay, 2 focuses, we call it 2 focuses. So they are not aligned at the same point and they do not orient in the same way. So usually, if we have a perfect circle, then common sense is that when it's perpendicular, that means it's in a normal direction. That means during opposition, it's supposed to be closest. But due to this shape of the orbit and orientation of the orbit, the opposition is not always the closest. In fact, most of the time, it's not the closest. So the closest may happen elsewhere at the orbit. Sometimes it actually is off by a few days, either a few days before or a few days after. So in this case, the closest approach for this year happened earlier on the 6th of October, and actual opposition is on the next week, 14. And then I also have compiled a list of the comparison between the, you can see that the date, then distance and the size of the mass between 2003 until 2035. Okay, you can see that on the left is the closest approach, the date and distant angular size of the closest approach. On the right is opposition. So if you notice, some of the year they happen on the same day. I think there's 1 or 2 years it happened on the same day. Let me check. No, I think all on the different day. I think some is off by 2 days or 3 days. Okay, but some off by about 7 days or so. Okay, so as you can see, I highlighted the 2003, 2018, and 2035 is where is closest during the 26 month. All of these are about 26 months apart, but not every 26 months it becomes as big as it will get lah. So some years is smaller, some year is bigger. So as you can see, it get bigger on the 2003 and then 2018, and next will be 2035.
Michael,
in fact, if you
after this, I give a more general explanation. Okay.
Yeah. So if you can see the size of the 2035 and last year is more or less about the same size, but still compared to 2003 is so much bigger. It's about half a degree bigger. But compared to last year, it's about 1 degree bigger. So as displayed by CK just now, one arc, sorry, not 1 degree, 1 arc second bigger. So 1 arc second bigger sometimes can make a very big difference. Depends on what you compare to.
So, Michael,
okay, so Chong pass to you.
No, you go back to the earlier one. We showed the orbit of Mars and Earth around. Yeah, this one. Okay. So the general explanation is why is the closest approach time and opposition time not the same? Or it's like this because the general comment is the solar system is not perfect. For example, you look at the orbit of Earth around Sun is an ellipse, and this ellipse will have a semi-major and a semi-minor axis from our geometry. So the Earth's orbit around the Sun has a semi-major axis. Similarly, also the orbit of Mars around the Sun also has a semi-major axis. So the answer is that the semi-major axis of the Earth is not the same as the semi-major axis of Mars. That's the reason. Because why? Because when the solar system was formed initially, when the protosolar nebula collapsed to form the Earth, of course form the Sun, the first thing, and then form the Earth to orbit around the Sun, and later on to form the Mars around the Sun, they are not perfect. So the orbits are not exactly the same. Close to a circle, but not close to a circle. So they are slightly off. So it's off opposition, and the closest approach off by plus or minus 1 week. All right. So that's it lah. Yeah.
Okay, so I have a question. I thought of one question. So since all the outer planets have experienced this opposition, so like we say, for the Mars is every year, every 2.5 years, every 26 months you will reach opposition, and then the size different by quite much as shown by William just now. Okay, between every 2 years or so, we can see the size changes a lot. Does it also happen to like Jupiter or Saturn? Why we don't have this kind of maniac fever about the opposition on Jupiter and Saturn, since they are also have this opposition thing, and they are supposed to have a different on the closest approach?
Actually, I give again a general answer is it's all because of gravity law. What gravity? The sun gravity law. The sun gravity pulls on the Earth. The sun gravity pull on Mars. The sun gravity pull on all the objects in the solar system. So actually, the general term for this is the orbits of, let's say, the planets around the sun compared to the other planets are sometimes in resonance. So say a certain planet will orbit the sun in 2 years, but the further away planet will orbit the sun in 3 years. So every time the inner planet orbit the sun in 2 years, the outer planet will orbit once in 3 years. 3 years means 3 Earth years. So this is in resonance. So there's a kind of order, but not necessarily that the same thing, like you said, you will have opposition for Saturn or Jupiter also. But there is a kind of
Well,
restlessness.
Dr. Chong, what I mean is, you see that for the Mars, between 1 year to another, the size can change a lot.
Yes.
Okay, but what about Saturn and Jupiter? Do their size change a lot during the 1 year between the years?
Yeah. So if we apply the same understanding of gravity of Earth orbiting the Sun, Mars orbiting the Sun, they're all in ellipse law, and their semi-major axis are not doesn't coincide. So similarly, we can also say that the opposition for Saturn and Jupiter also what they call different opposition would be different. But the problem with Saturn is, what is the time that Saturn will orbit the Sun? Many years. What is I don't know how Saturn very far. Saturn will orbit the Earth, I say, around once in about 80 years. So you want to wait another 80 years, 160 years. You must live for 160 years to see two opposition of Saturn. That is, the opposition of Uranus. Uranus will take 200 years to orbit around the Sun. So to see two opposition of Uranus, you need to live for 400 years. Whereas Saturn, Mars, every 2 years you can live. Jupiter and Saturn take longer time. You can see two opposition of Saturn, Jupiter, but you can see you need a longer time. So I think it's not worth it. You have to wait too long to compare two opposition of Saturn, let's say, or two opposition of Jupiter. So usually the inner planet. So we only have one planet to play with, where short enough time frame, 2 years and 2 months, and yet we can see the planet. Whereas Saturn and Jupiter take a longer time.
Actually, what I mean is for Mars to have an opposition is every 26 months, right?
Yeah.
But for Saturn and Jupiter, no, right? Every year we have an opposition, right?
No, there is opposition, but what you're saying is that you see, yeah. So imagine Saturn is so far away from the Sun that Saturn doesn't move with respect to the background star. So in a sense, there is an opposition of Mars every year. Every year the Earth goes around the Sun once a year. And always Saturn is always there, far away, doesn't move. So there's an opposition of the Saturn every year. And similarly for Jupiter also. So Jupiter is very far away from the Sun, further away than Mars. So Earth goes once a year around the Sun. So again, like every year, there's an opposition of Jupiter. So in a sense, there's an opposition for what? Every year for Jupiter, for Saturn, for Uranus, for Neptune. Because they just spread so far away, they don't move too much. In 1 year.
Why not on Mars? Why Mars has to be 26
in
months?
one Earth year? No, in 1 Earth year, Earth goes around the Sun in 1 Earth year. So in 1 Earth year, Mars will move a lot already. Because Mars is too near the Sun. That's why Mars keep on changing its orbit. That's why the Mars opposition is not every year. Because like this. Yeah.
Okay. So, CK and William, do you have anything to add on about the Mars?
William,
Yeah, you have. I have one more picture to share.
Okay.
Picture to share. Okay. So
your
just
picture.
Yeah, my picture. Just hold on.
I just Tunji, anything to say?
No, I think William wants to show.
Okay, William show first. Then I have another general comment.
Okay. Actually, I would like to show this image. You see, right? So on the left is actually the position the closest of this year, and the left is the closest on 2005. I don't know why. Coincidentally, both were closest. One is 2 hours apart. The left hand side is 2 hours after the closest, and the right one is 9 hours after the closest. Before the closest. Okay, and then I don't know why it's so coincident. Both of these image, the features is the same. The Mars face the same surface features to the Earth, and then I captured twice of these features on the Mars. This is what I would like to share. So excited that 2 times of this opposition, and another one is the orbit of the Mars and the relative position of the Earth and the Mars in 2020 is actually very close to this 2005. The distance almost like just a little bit of difference. So then it's actually at the same side of opposition. So this is also there is a similarity between the 2020 and 2005 Mars closest approach. So this is what I would like to share. Just how I constantly look at this, and then it has this kind of relation between the 2005 and 2020 of Mars closest. Yeah, and just how I saw there's Facebook, and one of the members asked about my image, that this image, why there is a missing one Mars opposition. I think that year actually very interesting. Actually, I missed the Mars opposition in 2010. What happened to 2010? The Mars opposition of 2010 actually happened on 28th of January that year. That time actually got another astronomical event happened in the sky. There is an annular solar eclipse, the longest annular solar eclipse. I think that year the longest. The annular of the solar eclipse actually lasts for 15 minutes. So that's a very big event. So then that one is overwhelming the Mars opposition. So then I missed that one. So that's the thing I would like to share. Yeah.
Okay, so CK,
Michael, can I say something?
Sure.
Okay, so I'm general thing, okay, So mark my words, please pay attention to this young multi-millionaire from South Africa, Elon Musk, all right? So he has made the big claim that he wants to send man to go on Mars and come back safely. And basically, that he wants to build a Martian, fully manned human space colony on Mars by the year 2050, in another 30 years' time, within another generation. Very big task, But I find very interesting, Elon Musk always wants to go to Mars, but he doesn't pay much attention to the moon, And I find that very surprising because we have known from in astronomy that if you want to go to Mars, the stepping stone is the moon. To go to Mars, you have to go to the moon first. But you fire a rocket from the Earth to the moon, you build a rocket on the moon, and for the moon you go to Mars, much less energy required, and easier to go to leave because the moon gravity is bigger, 1/6 the gravity of the Earth. To leave the moon to go to Mars is much easier. To leave the Earth and go to Mars is much more difficult. Right? So I don't know why he wants to go to the moon first. But we know that, in fact, they say that if man want to colonize the solar system, the first place, the stepping stone is always the moon. So actually now it seems there are two countries that are challenging each other. So you know what? The Americans are back, NASA is back. So NASA is going to have another moon mission to go to the moon, and called China Space Agency. So these two countries in the world want to go to the moon with the hope that the moon will be a stepping stone to go to Mars. So eventually they go to Mars. And do you mean to say that once you go to Mars, that's the end? No, we have been reading science fiction stories for years and years. So in the high school, we have read that for famous science fiction authors, of course, the moon first, the Mars, then Mars what? Then asteroid mining, to get all the important resources from this asteroid belt, and later on go and colonize. This is, you may say that I'm really exaggerating that colonize the whole solar system. Man colonization of the whole solar system. And remember, some of the story of the science fiction story, there is a father and a son now standing on one of the moons of Saturn with a permanent human base in the moon of Saturn, looking back very tiny object far away, the tiny blue dot Earth. And the father tells the son, no, boy, the grandfather left that blue dot years ago and God came to the moon of Saturn, and we are here. Man, we have set up our own home here. So in future, man will colonize the solar system. And not the end. Some of the science fiction stories say, is that the end? So I use the word the prison of the solar system. The universe is so big. So the solar system is a tiny spot. We are in the jail called the solar system. So what? You build a hyperdrive, worm drive. You tunnel through space-time, like you see in all the what you call the science fiction movies, all right? That you tunnel through space-time. You what? You have to explore the Milky Way, explore and colonize the universe. That's the ultimate aim, all right? So this is it. So open your mind. So that's why I say once they break the door to Mars, they start interested to go have to explore more Mars. Then the future destiny of man will be the solar system and hopefully the universe. So that's the whole idea. Yeah.
So, CK, how is the weather there?
Right now, I think it still looks bad. I don't
William,
know.
how is your place?
My place now. Just now I look at the all sky camera is still bad, but Jupiter and Saturn.
Okay, so
Saturn can see, but the side of the Mars cannot see. Yeah.
So possible are you connecting your telescope to Saturn and Jupiter?
I'm now inside the room, but then my equipment is outside, so maybe need to. I also to know now it's still okay or not. But my home actually blocking the side where the Saturn and Jupiter.
Oh, okay. Never mind. In that case, Dr. Chong, maybe we can talk about the Space Week.
Yeah, just before saying one more thing about Mars is now this is a long time dream of the planetologists. What are the planetologists? The people who study planet and they do what? Comparative planetology. They compare the Earth with Mars with Jupiter and so on. So now these scientists have been waiting for years to get samples of Mars to study on the Earth. So remember the Chinese Tianwen mission, they will collect certain samples of Mars and put in the capsule and leave it on the surface of Mars to wait for future China mission to go to Mars and bring back those Martian soil and rock back to the Earth. Same thing with Perseverance. They also collect a lot of Martian rocks and soil, put in the capsule, and in 2032, 12 years later, another mission by the Europeans and Americans who land on Mars and will bring back the Mars sample kept in the capsule by this Perseverance rover and bring the Mars sample back to Earth. So the scientists have been waiting for years and years to study the Martian rock. So hopefully their life's aim will become true. Because when you get the actual sample of Mars to study, you learn so much information about Mars to know. Of course, for years and years, we have known that there are many Martian meteorites. The meteorites that fell onto the Earth because of Mars. Most of the Martian meteorites are discovered in the South Pole, in the ice cap. So the idea is that years ago, a big object, an asteroid, hit Mars, and a lot of material blown up from Mars, orbit the solar system for many years, and some of them fell into the Earth. And because in the ice cap, you can easily see the meteorites from Mars they found. They also found Martian meteorites in India, in Southwest America, and also in Egypt. So the Martian meteorites are very, very expensive, right? Very, very expensive. So now they hope to bring back the actual in situ samples from Mars back to the Earth, right? So that's exciting. Of course, another one is interesting. Now the Japanese are waiting for what? This month, October, what? Hayabusa 2. Remember, the Japanese sent a second robotic mission to land on the asteroid called Ryugu. Japanese named the asteroid Ryugu, and they took some sample of Ryugu on the way back to the Earth and to land in where? In the Australia, South Australia, near Adelaide. Remember many years ago, the British tested the atomic bomb in Australia. The Woomera test range there. So this sample is on the way back to the Earth now from the Japanese Hayabusa 2 robotic mission with the Ryugu sample. They're going to burn through the Earth's atmosphere, parachute and land in South Australia, and the Japanese will study. So this is another second successful, hopefully, sample return mission from an asteroid. So a lot of things are happening. All right, Martian rocks from Mars coming there. Yeah.
So anything add on for the World Space Week?
Yeah, World Space, as I said earlier, is actually we are now at the tail end of it. It's from the 4th of October to the 10th of October. You remember, Chong, many years ago, our USM Astronomical, we have built the Doctrine telescope now. So what we do? Capitol Cinema Penang. This Kongka already built. So many of the public area, we put our one or two Doctrine telescope to look at the moon, to look at the object. So we celebrated World Astronomy Day. And that time we started Astronomy Day. But later on, it was so popular, they do it in April and in October. And then later on, they expanded to one whole week. So now it's World Space Week, not day. 4th of October to 10th of October. And if you look at the main website, which is sponsored by the United Nations, it has exploded, So this year, World Space Week is celebrated in 90 over countries around the world, 4,000 events. every day there are a lot of events. But I was very surprised. I just checked earlier that there's one country that is not on the list, China. Many countries are in. Singapore, Malaysia also got 3 events. Many countries. And the country with the most events was Pakistan. many schools, hundreds of schools. And of course, Brazil also got, all right? Of course, UK also got, but China don't have. So this is World Space Week. And the theme for this week is Satellites Improve the Life. Last year was the moon gateway to the stars. All right? So this year is satellite improve life. So there are a lot of events about satellite. Next year, ladies and girls, please pay attention. Next year, the theme will be Women and Space. Women in Space. All right? So this year is Satellites Improve Life. So of course, we know the satellite, first one was October the 4th, 1957, Sputnik 1, no? So now there are so many satellites orbiting around the Earth and also all around the solar system. And 4 of them are going away from the solar system. Pioneer 9, Pioneer 10, Pioneer 10, Pioneer 11, Voyager 1 and 2. All right. So there are many satellites. Some of them are actually orbiting the sun. Some of them are all like haywire around the solar system. 4 are leaving the solar system. And there are thousands and thousands around Earth orbit. So there are all kinds of satellite, weather satellite, to see the agriculture, all kinds of uses there for satellite. Of course, still we know this is not reported officially, but we know one of the main uses of satellite is what? Military spying weapons so all kinds of things, So satellite have actually changed human life. So I said, so you can keep on talking how it has affected us, right? Satellite have changed our life, all right?
Okay, so anything else you want to add on about for the session today? Okay, if not, allow me to do a advertisement. Okay, let me check.
Go ahead.
Finishing now. Come. Yeah. Because I didn't know that. Okay.
Okay, so for everyone, just for your information, we have this is actually the second year we are organizing this astrophotography contest. Okay. This year we are supported by the Starfinder Astronomical Society. Okay, so the contest, the submission deadline is the end of this month. So if you have taken any nice photo of all the celestial objects, nebula, moon, Saturn, whatever, Milky Way, okay, as long as they are taken in Malaysia and last year and this year, you can send them to us. Okay, so we hope to receive your submission very soon. So if there's nothing else, then I think we may end our session today.
Yeah. Thank you, Michael, for arranging. Thank you, William.
So thank you, Dr. Chong and William and also CK for being with us tonight. And thank you everyone for joining us. Okay, we'll see you again next month. End of this month. On the 31st, we will have an airport tour for this month. So we'll see you again. Okay, thank you everyone. Good night.
Okay, good night. Bye-bye.
Hopefully the weather's clear up, then we can go up and look at the Mars. Okay, before we get too old in 2035.
Yeah.
For those who are still young, it's okay but for us, it's a bit too old.
Oh, William has been comment not too long, no? Stay healthy.
Yes.
I saw. Plus 76 years, 76 years plus. Can see.
Still strong.
I think by 2035, I'm between Dr. Chong and CK at my age. 55. All right, okay. So we shall end our session tonight. So thank you everyone again. Good night.